Yeah, my name is Bogdan. I'm working for Idealo. Do you know Idealo? Yeah. Thank you. Thank you. But Idealo, we can also tell you about this a little bit in numbers. Yeah. So we operating in 6 European countries. We have 76 million visits per month, 4.5 billion offer imports and updates per day. To make our inventory bigger and satisfy you with buying the best product with the good prices. And we have 5 million active products. So this is something from where we can review the recommendations. And we certified a climate neutral and price comparison portal. So good for our Earth. But for those who doesn't know about Idealo, what we're doing, we scraping internet and trying to find the best offer for you by price, and also some additional for that it is the delivery cost. So we're also checking if the delivery cost is too high and so on, and we can give you this best price. And very important feature that you can see how the price change over the time, and we have this price tracker. So you can set up alert, and with this alert, you can say what price you wanted to buy the product, and then we can give you this alert when the price will be dropped. Okay, this is about Idealo, and what we're doing there in Idealo, in order to make you happy, we're sending you recommendations. Yeah, because we hope that these recommendations will help you to make decisions, and we as a machine learning engineers, we making these recommendations. Yeah, most of the time it's like our main focus to make these recommendations. And in order to do this, all of these recommendations, it's kind of a hypothesis, yeah, that that happens in the mind. And like very easy hypothesis is if we send you just bestseller products, and then probably you will buy them, but also we wanted to add some personalization for that. This is another hypothesis that we wanted to evaluate and check. Also, maybe the color of the products is something that you would like this Mario, for instance, controller for the Switch. We have this recommendation not only in the mail campaigns, but we also have this recommendation on the website, on the also mobile portal, and you see that different recommendations happening at the different stage. For instance, we can recommend you some bargains. We can recommend you some products that based on your visited history, if you allow us to use your visited history. And also we can create some kind of like local offers, because sometimes we can offer better for the delivery from specific like local regions, yeah, like from the Berlin, and also similar products. And all of this hypothesis, it is what is standing behind it. It is a pipeline, yeah, that we need to kind of create. We need to kind of first of all identify, yeah, what is the idea, yeah, and we have this quote. We are not just limited by technology, but by our ideas and our experimentation and how quickly we can try things. And for us, when we're doing the recommendations, we don't want to have a limitation. We want that everybody in our company can come up with the idea, and we can just implement this idea and try and see does it work on the target groups, not like on all the users, but on the target groups. And for that, what we need to do, we need to run kind of like A/B test experiments, or maybe somehow at the very beginning, of course, we try to measure if this idea works good with the offline metrics, where we can analyze. And how it works, yeah, we have business needs, we have a data that we can try. Then what the next step, it is develop a model, and then we train model, then we test model, deploy model, connect this to the business applications. If it's like a marketing campaign, we're sending this into the emails. If it's on the web page, it's showing on the web page. And then we monitor, optimize, see the results. And we try this cycle every time, and like over and over. And the idea to make this cycle as fast as possible, because if you have idea and you wanted to see how this idea performs, you don't want to wait months, like years, you want to have it as quickly as possible. And the amount of ideas that you can use and implement, this is also something that we need to be able to parallelize, yeah, the number of the ideas that we can evaluate at the same time. And I have my background, it is DevOps, so it looks like a very good match, yeah, so even the color is the same, yeah? So we have like also plan, yeah, and then we code. Plan is our business needs, yeah, then we code it, we build the model, we test the model, we release it, deploy, operate, monitor, and continue. So it's like very nice match, yeah, like our machine learning life cycle and DevOps life cycle. So everything works good. And now let's take a look how we can apply these DevOps practices, which working already for quite a long time, and how we can apply this with our machine learning pipelines. Okay, first part, yeah, it is plan, code, build, test. So for the plan, it's just idea. People come up with ideas, say, okay, let's today try to show like the products that user already see. It's a valid idea, so let's just enable them with the product that they already see. And then we go in with the code, we're going to build. And then the question is, if we code it, where are we going to deploy it? Yeah. And in recent years, we migrated all our infrastructure into the AWS. And at AWS, we have AWS SageMaker pipelines, which is, before it was just SageMaker pipeline, now it is SageMaker AI pipeline, where you can see that all of the steps is as independent container, and each of this independent container, it has input data and produce output data. Pretty simple architecture, and you can combine all of these containers in some of the chains. You can see it can be like a tree, it can run several steps in parallel, there can be different steps. In order to code it, oops, sorry, okay. Yeah, in order to code it, it's quite simple. So you can just say, hey, it is my input, hey, it is my output, the processing step, and then you put like this inputs, outputs, and then the processing step. And what is the processing step? It is only this, the processing code, which is running here. It's a simple Python script. And the Python script gets as the input parameters, it is all inputs, and then where to store it. And then after you create all of the steps, you need to combine them together in some of the pipeline. And this is the pipeline. Also very simple interface, as you can see. It is like few lines of code and how you can define your pipeline. You have parameters, instance type, training type, all of this input data, the batch data, and then also the steps, how they join together. But in order to check all of the steps, we also need to test them, yeah? Because for us, we select this PyTest BDD framework where we test in each step. And because we have also a lot of the different pipelines, different hypotheses, different people working on these pipelines, it is also a way for us to communicate. Because if you're looking into the code, sometimes it's like code quite chatty and it is hard to read the code. But this BDD test, we find out that this is quite easy to read, understand. And for most of you, I guess, it's also understandable what it's actually doing. Yeah, so it is getting some input data. There is a temporary directory that contains the data. When we call our post-process result Py with these arguments, we can then expecting that there are some like output CSV files. And this is the way how we communicate also between like different teams inside the team, that instead of like checking the code, checking all of the steps, we can just read this simple test case and kind of like a documentation. Okay. Yeah, this is the pipeline. Also, in order to run these pipelines, what we find difficult, pipeline needs to spin up a new instance every time. It takes approximately like 60 seconds, maybe 2 minutes, depending on the instance type, because we're using also GPU instances. It takes a little bit longer. And in order to do this, in AWS, they provide local pipeline session, which allows you to run all of these Docker containers on your local environment. Under the hood, it runs everything as a Docker compose, and then everything running inside. What is the benefit for us? It is speed up our integration tests dramatically. So it took us, instead of waiting when it's starting several minutes, like 5-10 minutes when it goes on the AWS infrastructure, on the local computer it takes several seconds. And we can also test it. Most of the cases where we find it's difficult, it is how we combine all of these processing steps together, because sometimes you're expecting like CSV files, sometimes you're expecting different file names as the input, and they have not connected very well together, and waiting this on AWS infrastructure takes a lot of time, and this you can test easily, manually, locally, quite fast. What we then decided that if we create each pipeline, we decided that for each pipeline it is nice to have it as a separate repo. Why? Because separate repo, we can also run for this separate repo specific GitHub actions. We can install specific packages, versions of the packages. As you know, the problem with the packages that sometimes when they update them, it doesn't mean that they work better. They sometimes work, they add some additional bugs or some additional not expected behavior. And if you have like hundreds of different pipelines, managing it is like in one big chunk, it's hard. This is why we decided to separate, and each pipeline has its separate repository. As you can see, we have like different pipelines. Like we have GPU training, GPU training on the tracking ID, GPU training on the product ID. This is also something that we come up with our naming conventions that helps us to understand what is about. Yeah, what are changes there. Okay, so what is cool? Oh, you don't see anything from there. My fault, sorry, the wrong colors. So the test should be simple and fast. Everyone should be able to understand the test. This is why we're using this BDD framework. And we have to test only what matters. If you have input and you test output, it is nice because you don't test implementation, you test actually how the system behaves with the data. The second part, it is how we manage releases, deployment operations, and how we do monitoring. So what, from the DevOps, we find out that each pipeline, it is a simple artifact. It contains everything inside. It contains all of the scripts. It contains all of the artifacts that it's necessary to run. Also, we pack libraries together. And how it helps us that when we run it, we exactly knows that it runs with exactly the same code, with exactly the same libraries. And if it fails, we can just take this artifact, run this locally, and check and verify what actually the problem happening. And when we deploy, we're quite confident because it does not break on the production. Yeah, so it's running exactly the same code. The only way why it can fail, maybe the data change it, or maybe, I don't know, just instance crash it for some reason. How we then deploy this as a code? Because each of these pipeline definition and this can be versioned, and for each pipeline we create a separate repo, we can create a very easy release process because it is just functions in the GitHub where we can just click a button, release, and then it will be automatically released for us. And in order to deliver it to the AWS, we use Terraform for that. Yeah, so Terraform, it is declarative, it is very nice because you define what you want, and then the Terraform tries to achieve this state. So this is why we using Terraform for that. And because we have a lot of the pipelines, we run in different pipelines in different accounts. So it means that if one account is failed or some problems, we don't have like the problems with the noisy neighbors where we can, for instance, put a lot of data in one account and then some reason it does not work. So we can really deploy which version of the pipeline in which account and also track the amount of the money we spent for the specific account, which is for the cost analysis is quite important. And in order to operate Terraform, we use TerraGrant. TerraGrant, it is very nice because in the Terraform, if you have a lot of pipelines, all of these pipelines takes quite a lot of time to apply this Terraform configuration, because Terraform under the hood, what it needs, it every time calls AWS API and ask if there are some changes or not, and then try to match and then create a plan. With the TerraGrant, we operated on the level where it is only checking the changes for the specific pipeline, run everything in parallel. And this is, yeah, we need for that bigger machines because it runs several in parallel, but it will increase the time we need. And if we need to only deploy and check one pipeline, we can easily do this within this TerraGrant configuration. And last but not least, this is GitHub to monitor the changes. So everybody is creating a pull request. We verify if this pull request is good, and we can see then at the end the history of the changes on our infrastructure. So instead of going into the AWS and checks what's wrong, we can see, okay, who did the change, when this change was done, and what exactly was changed in our infrastructure. And we use GitHub history also as a tool for us to understand what is going on with our current pipeline. Okay. Oh yeah, there is still some. What is important to understand when we have a pipeline as artifact? It is that each pipeline is well defined. Everybody can take this pipeline and run locally with the local mode and check if something doesn't work. Of course, there is a problem if you don't have GPU specific, then it does not work one-to-one. Then when we deploy the specific version of the pipeline, for us it is important that we can easily roll back. And roll back, it takes literally seconds, because you just change the version of the pipeline that you want to deploy, do the pull request, approve the pull request, and then it will immediately goes into the production and deploy the specific version. And what we then, if we have this everything versioned and packed, we don't have side effects. Everything which is running with the specific version, we know that it would be run all the time exactly the same. Yeah, what we can do is we can deploy, develop independently. Everybody can develop its own hypothesis. They can develop its own pipeline version. Verify and deploy and release they independently. Because when we release it doesn't mean that it is already in production. When we deploy this in the production, it only happens there. So it means that everybody can push into the main without any problems, changes for the pipeline, but only these changes will be on the production when they release an artifact, and when this artifact will be deployed into our architecture, infrastructure. And because each pipeline is independent, we can use different frameworks. If you like PyTorch, TensorFlow, you can use this. If you like different languages, you can use different languages. The only that we have to use this BDD framework when we can easily see what the input, what the script we run and what the output. So downsides, because we have different pipelines, we have a lot of code duplications, and resource usage is not optimal. Sometimes you have hypotheses where you can say, okay, I wanted to run only for this specific group of the product, and for them we need to train specific model for that. What it means that if we write everything from the scratch, no, we just copy the code from the pipeline, create exactly the same, and then see if it's like working, this hypothesis is good. Then we archive the previous repository, but during the time when we verify, we still have two code bases, which is almost exactly the same, but with some small changes inside. So it is the code duplications. The way how we're trying to make it, we're creating some libraries, but yeah, this is how we try to avoid these code duplications. And resource usage is not optimal, because if you have exactly the same pipeline, you need to think about the caching, but maybe for some pipeline you have different query parameters, different data sources. So caching is not always the same, but yeah, in resources you need to sometimes to duplicate. Okay, and that's it. Please, questions? Okay.
Oh, thank you so much, Bogdan. So you are exactly right on time. I was about to show you the card, but then you were like, okay. I've got quite a few questions. Oh, more than 15. Not really sure if you can manage all of them, but let's see how many you can answer. So the first one is, what is Idealo's business model?
Oh, nice question. I'm not the right person to answer this, but in short, we have contracts with merchants, yeah, with the small, with the shops, with big shops, with small shops, and they sending us data. Then also we have another possibility to have like an open catalog where we get all of the offers from the internet. The problem is when we have a contract with the shops, we have very well structured data. When we have open catalog, the data is not well structured, so we cannot really recognize all the offers. For that, we're using machine learning. We're trying to recognize offers by description, by some attributes, and image recognition. So if we recognize some images, we can say it's the same product or it is different products. And then we, from you, what is important that it's like not necessary for you to register on our website. The only registration is needed if you wanted to have notifications and email campaigns. But if you wanted to have notifications, you just need to install the app, and then that would be push notifications without any registrations needed, which is I guess good. Yeah.
Perfect, thank you. And the next one, do you need to deal with sensitive customer data at Idealo? Mm-hmm. And if yes, how do you solve privacy issues when working with AWS Cloud?
Mm-hmm. Yeah, so for us, we do not store and do not use any user data, even like a sensitive user data. So there are some interactions that we see in our system, but they anonymize. So we don't have any connections between who you are and so on. And in order to have this email campaign, you need to register, and you need to click a button that you wanted to get this email notifications, and then we use your email hash. So we don't know even your email, we only use email hashes. So it's like pretty safe.
Thank you. And the next one, if you have a separate repo for each pipeline, how do you manage to keep standards and learn and improve the code and structure from new projects?
Mm. Yeah, the problem was it's still code duplications, and for the standards, we use automated linters, automated the test, and in order to communicate, we communicate inside the team with the test suites. As you can see, it is like very simple, and we do not really care about what framework you're using, but what we care that this should be reproducible and replicated. Whenever you run this with the testing, like we have integration test, it should just to be well tested. And for the test coverage, we have the metrics like it's like 90% for the test coverage, which is trying to achieve metrics.
Yeah, thank you. Do you have ML pipeline sharing common steps? How do you realize that if they are stored in different repositories?
Yeah, this is the problem with the usage, not optimal usage for the resources. In order to have the common steps, what we're doing, we creating our own caching mechanism. When we call the pipeline step, each pipeline step, it has its own unique hash based on the query parameters that we have in this step and the version of the step. And then we can reuse this step. So it is not aligned, because if it works very good in the SageMaker, if you have one big pipeline, then you can cache steps. But if we use different modern, different pipelines, we cannot really cache the steps. So we created our own wheel for that to manage it.
Perfect, thank you. I think this is also my favorite question. So are you fully satisfied with cloud resources, or sometimes want to return back to on-prem things?
Oh yeah, what I like that it is everything fully managed, and when we need some support from AWS, they're quite open, and they always fully support us because we have this business support, and this is like very nice. But what I see sometimes, if you have a product which you really like, and then AWS changed this product, which doesn't happen so often, so you don't have any possibility. You have to also change, and sometimes it's not so easy to change everything. Yeah, if you have hundreds of pipelines.
Yeah, agreed. And the next one, could you elaborate on your multi-user approach when it comes to running pipelines?
Multi-users, I think it's multi-accounts, yeah? Or maybe. Yeah, so multi-user approach. When we have multi-accounts, it means that we can easily check which account to which team belongs, which product we calculating, and we can also see how much cost we spending on this particular campaign, on this particular slider that we have on the website, on the mobile application. And this is how we solve it with the multi-accounts. And also for the multi-accounts, we have different data sources and different data permissions that we can also manage.
Okay. How do data scientists write their code for processing and training steps? Do they use SageMaker Studio or personal laptops?
SageMaker Studio. So everything, all of the Jupyter notebooks we running on the SageMaker Studio. Right now, the new version of the SageMaker Studio works quite fast, well, and yeah, it just works. So you don't need to run it on your local computer anymore.
Yeah. So looking at the time, we have one last minute. Most probably, we might not finish all the questions, but we'll try to cover them in Discord. The last one: if the pipeline tests run locally, what about intermediate results that are very large and would usually be stored remotely? Do you mock test data?
So what we're doing, of course, you cannot download on your laptop like 60 gigabytes of the data of the products that you have. What we're doing for the integration test, we're running with the small data sets. So we're using like very small data sets, like 10 megabytes data set, which we running on local computer. And on local computer, it works quite fast. And also, of course, the problem that if you don't have GPU and you wanted to run and test GPU code, which is running on your local computer, we're using for that some kind of like wrappers, which not 100% tell you that it will work in production. So this is something that we cannot do. And if it's running on your silicon processor, it has also some problems with the different architectures. So something also needs to be considered. What we tested in the integration test, only that all of the components connected together and all of the interfaces that we define, they works together. So this is what we test in integration test.
Yeah, perfect. So thank you so much for those amazing answers. And with that question, we would like to conclude. And please give a round of applause to Bogdan.
Yeah, thank you.